In this video, we're going to look at how we can use partial fraction decomposition to do integration. And so one thing I just want you to recall back from this section is that we showed really quickly, let's say for instance you want to integrate like 3 over x minus 5 dx. And the result of that was they kind of followed a pattern. As long as this is just x minus 5 and we don't have any exponents or anything like that going on in the denominator, the result that this would be 3 times the natural log absolute value of x minus 5 plus c. So the idea is if we can make something look like this, it's very easy for us to do the integration techniques. So we're going to use partial fraction to try and actually make something look like this: a over x minus 2 plus b over x plus 1 plus c over x minus 3. So let's start first with the partial fraction decomposition. We want to take 3x squared minus 8x plus 1 over x cubed minus 4x squared plus x plus 6, and we're going to make it look somehow like a over x minus 2 plus b over x plus 1 plus c over x minus 3. So we're going to actually multiply through by a common denominator. So let's do that first. Alright, so we're essentially multiplying through by those three terms, and let's see what we're left with. So we're going to assume this x minus 2, x plus 1, x minus 3, that's really just whatever this denominator was here. So that cancels out. We've got 3x squared minus 8x plus 1 equals. Here we're going to lose this x minus 2 term. So we're going to have a times x plus 1, x minus 3. Here we're going to lose this x plus 1 term, so we're going to have plus a b times x minus 2, x minus 3. And here we're going to lose this x minus 3, so we're going to get plus a c times x minus 2, x plus 1. Alright, so let's multiply that whole right side out. So if we were to multiply that whole right side out, here's what we would have. So if we multiplied each one of those binomial terms, we would have a line that looks like this. So now you have a times this polynomial plus b times this one plus c times this one. And so now let's distribute in that a, b, and c. And the next line you would be this one. Okay? So we get this line after multiplying everything out, and what we want to do is gather up the terms of x squared, gather up the terms of just x, and then gather up our constant terms. So if we gather those terms up and just rearrange this, we're going to end up with this line. And so now that we have this line, the reason we wanted that is we want to see what really is being multiplied together to essentially make this x squared term. So we've got 3x squared minus 8x plus 1. And I'm going to factor out the a, the b, and the c here. So you would have a plus b plus c times x squared. Now factoring out the terms of our x, you would have a plus negative 2a minus 5b minus c times x, and then our constant term, negative 3a plus 6b minus 2c. And so the whole reason that we did that is actually we're going to set up kind of a matrix, and what we want is a plus b plus c to give us 3. We want negative 2a minus 5b minus c to give us a negative 8. And we want this negative 3a plus 6b minus 2c to actually give us a positive 1. So I'm going to jump to the next page, and we're going to set up this kind of linear system that we're going to solve. And so just kind of gathering those terms, what we had was that we want a plus b plus c to give us 3, negative 2a minus 5b minus c to give us negative 8, and negative 3a plus 6b minus 2c equals 1. And so what that makes is a linear system, and you may or may not recall, we use the graphing calculator to solve these systems. I'll post a video below this on how to use your graphing calculator again to do matrices. But essentially what's happening here is we have this matrix 1, 1, 1, 3, negative 2, negative 5, negative 1, negative 8, and negative 3, 6, negative 2, and 1. And what we did is used our graphing calculator, and we showed that this actually becomes 1, 0, 0, 1. 0, 1, 0, 1, and 0, 0, 1, 1. And again, I'll post a video about how you can do that matrix in your graphing calculator. But what we've actually shown is A is 1, B is 1, and C is 1 with this matrix, right? This is my A value, my B value, and my C value here. So essentially what we're doing is we're taking the original indefinite integral 3x squared minus 8x plus 1 over x cubed minus 4x squared plus x plus 6 dx, and we can rewrite that as 1 over x minus 2 plus 1 over x plus 1 plus 1 over x minus 3 dx. And if we integrate each one of those terms, we're going to get the natural log absolute value of x minus 2 plus natural log absolute value of x plus 1 plus natural log absolute value of x minus 3, and we always add in our plus c. And that would be our final answer. If you would have had something other than 1, 1, and 1 there, like maybe a 2 over x minus 2, then you would have had 2 natural log x minus 2 or something in that instance. But this matrix worked out really nice, and that's why we ended up with 1, 1, 1.